International Code of Safety for ships using gases or other low-flashpoint fuels, IGF Code. The IGF Code aims to provide mandatory safety standards for ships using low-flashpoint fuels, such as liquefied natural gas, LNG, to minimize risks to the ship, its crew, and the environment. It achieves this by establishing functional requirements and regulations for the design, installation, control, monitoring, and operation of the machinery systems involved in using these fuels. The IGF Code addresses all necessary considerations for the safe use of these alternative fuels, which are crucial for the shipping industry's transition towards cleaner energy sources. The IGF Code was adopted on June 11, 2015 and entered into force on January 1, 2017. Primary goal: Chapter 3.1 to provide for safe and environmentally friendly design, construction and operation of ships and their installations using gas or low-flashpoint fuel. Basic philosophy of IGF Code: to provide mandatory provisions for the arrangement, installation, control, and monitoring of machinery, equipment, and systems using low-flashpoint fuel. This is done to minimize the risk to the ship, its crew, and the environment. The philosophy utilizes the goal-based approach, MSC.1/Circ 1394. Key functional requirements. Safety equivalence. The safety, reliability, and dependability of the systems must be equivalent to that achieved with new and comparable conventional oil-fueled main and auxiliary machinery. Risk mitigation. The probability and consequences of fuel-related hazards must be limited to a minimum through arrangement and system design, example, ventilation, detection. Unacceptable power loss. The design must ensure that safety actions taken due to gas leakage do not lead to an unacceptable loss of power. Single failure criterion. A single failure in a technical system or component shall not lead to an unsafe or unreliable situation. Current scope. The current version of the code primarily includes regulations to meet the functional requirements for natural gas fuel, LNG/CNG. Regulations for other low-flashpoint fuels will be added later. Defining hazards and mitigation. Low-flashpoint fuel means gaseous or liquid fuel having a flashpoint lower than otherwise permitted under SOLAS Regulation 2-2/4. Example: liquefied natural gas, LNG, and compressed natural gas, CNG. Hazardous area. An area where an explosive gas atmosphere is or may be expected to be present, requiring special precautions for equipment. LEL, lower explosive limit alarm at 20% LEL and safety system activation at 40% LEL on 2 detectors. Fuel containment system, FCS, the arrangement for fuel storage, including barriers and tank connections. Secondary barrier. The liquid-resisting outer element designed to provide temporary containment of liquid fuel leakage and prevent the ship's structure temperature from dropping to an unsafe level. Tank connection space. A space surrounding all tank connections and valves in enclosed spaces. Emergency systems. ESD. Emergency shutdown, a system designed to automatically shut down machinery or non-safe equipment in the event of abnormal gas hazards. Double block and bleed valve. A set of 2 valves in series plus a third valve enabling pressure release from the pipe section between the 2 valves. Engine room safety. The IGF Code mandates specific concepts for machinery spaces containing gas-fueled machinery to minimize explosion probability. Gas release risk. Single failure. A single failure cannot lead to the release of fuel gas into the machinery space. A single failure may result in a gas release into the space. Fuel piping protection. All fuel piping must be enclosed in a gas-tight enclosure, double pipe or duct. Gas supply piping may be accepted without a gas-tight external enclosure under specific conditions, example, redundancy and certified safe equipment. Operation. Considered gas safe under all conditions, normal/abnormal. Considered non-hazardous under normal conditions, but may become hazardous under abnormal conditions. Safety action. Relies on primary containment and enclosures. If abnormal conditions, gas hazards, occur, automatic emergency shutdown of non-safe equipment, ignition sources, and machinery must be executed. Explosion pressure relief devices cover severe failures. Ventilation rate. Requires double pipe ventilation. Requires ventilation with a capacity of at least 30 air changes per hour or 15 ACH normally, increasing to 30 ACH if gas is detected. Explosion prevention. Explosion limitation. An explosion in any space containing potential sources of release must not cause damage that would 1. Disrupt equipment in other spaces. 2. Damage the ship leading to flooding below the main deck. 3. To injure personnel in accommodation or work areas. 4. Disrupt control stations or switchboard rooms necessary for power distribution. 5. Damage life-saving equipment. Hazardous area zone. Zone 0. Interiors of fuel tanks, vent pipes, and equipment containing fuel. Precautions. Equipment must be minimized and certified safe for the environment. Zone 1. Tank connection spaces, fuel storage hold spaces. Areas on open deck within 3 m of gas outlets, bunker manifolds, or fuel preparation room ventilation outlets. Precautions. Electrical equipment must be certified safe for Zone 1. Emergency shutdown, ESD. Protected machinery spaces require equipment necessary for operation during a gas leak to be Zone 1 certified. Zone 2. Areas within 1.5 m surrounding open or semi-enclosed Zone 1 spaces. Precautions. Electrical equipment generally excluded unless essential. Electrical systems in ESD spaces. In ESD-protected machinery spaces, all electrical equipment not certified for Zone 1 must be automatically disconnected if gas concentration above 40% LEL. Bunkering and operational requirements. The bunkering station must be located on the open deck for sufficient natural ventilation. It must be arranged so that any damage to piping does not damage the fuel containment system. A dry chemical powder fixed extinguishing system must be installed in the bunkering station area. The area requires protection from unacceptable cooling in case of fuel leakage. Bunkering procedures. Master, ship PIC, and the bunker representative, bunkering source PIC must agree in writing to the transfer procedure, including flow rate and volume, emergency actions, and complete and sign the bunker safety checklist. Upon completion, the ship PIC receives and signs an LNG bunker delivery note. Documentation. A copy of the IGF Code, or national regulations, must be on board. The ship must be provided with a detailed fuel handling manual for safe operation of the bunkering, storage, and transfer systems. This manual must cover system limitations, example, filling limits, cool-down rates, and emergency procedures. A fuel system schematic must be permanently mounted in the bunker control station and bunker station. Training and drills. Seafarers responsible for designated safety duties should complete basic training. STCW Table A 5/3-1. Masters, engineering officers, and all personnel with immediate responsibility for the care and use of fuels and fuel systems should complete advanced training. STCW Code Table A 5/3-2. Drills. Emergency drills and exercises must be conducted at regular intervals. These include reviewing fueling procedures, testing equipment for contingency response, and ensuring personnel are trained for the assigned duties during fueling. Recent amendments, effective January 1, 2024. New definition introduced for a ship constructed on or after January 1, 2024. For these newer ships, the fuel storage hold space, cofferdam, for Type C tanks is subject to stricter separation requirements. Example, not directly above Category A machinery spaces, and a minimum distance of 900 mm to the A60 boundary. New requirements for fixed fire extinguishing systems in fuel preparation rooms for new ships. Future developments. IGF Code review and focus on alternate fuel. The current version focuses on natural gas fuel. Regulations for other low-flashpoint fuels will be added as they are developed by IMO. In the meantime, compliance for other fuels must be demonstrated through alternative design. IMO will periodically review the code, taking into account experience and technical developments. Thank you for watching the video. For more marine topics, please subscribe the channel. Please help us with your valuable feedback to improve the contents.